All right, we are going to talk about the constant of proportionality. There are three ways that you can tell if a relationship is proportional. You can tell from the graphs, from tables, or from equations. Our book actually splits this up into 3 lessons, but I'm going to make one video for the whole thing. So first of all, what is the constant of proportionality? So if we have a proportional relationship, which we're going to talk about throughout these notes, the ratio of y to x is the constant of proportionality. And we use the variable k to represent that constant of proportionality. Why the letter k? I'm not sure, but that's what we use. So to find that constant of proportionality, or k, we are going to divide, right? Because it's a ratio or a fraction, and a fraction means divide. We're going to divide y by x. And you're going to hear me say this over and over and over and over again in this module. So let's start with the easiest way. Oh, first let's answer this question right here. The constant of proportionality is the same thing as the unit rate. So it's how much for 1. All right, the easiest way to tell if a relationship is proportional is from the graph. So a graph has to be 2 things in order to show a proportional relationship. It needs to be a straight line. Sometimes you'll hear them say it needs to be linear, which means straight line. And it passes through the origin, which we know is the point 0, 0. So it has to be both of those things. Over here, this is a proportional relationship. And we know that's true because this line right here is a straight line and it goes through the origin 0, 0. So it's asking us, what is k? Remember that k is the constant of proportionality and k is y over x. So you might be thinking, what is y and what is x? What does that even mean? Well, this is the x-axis, as you know, and this is the y-axis. And we can find a point on our graph. Here's one right here. And let's label that. That's the point 1, 2, and 1, 2, 3, the point 2, 3. So we can use any point on that line and put y over x. The first number is the x, the second number is the y. So if we do y over x, we're doing 3 over 2. And that's my constant of proportionality. So it's important to note that only proportional relationships have a constant of proportionality. If it's not a proportional relationship, there isn't one. So let's look at this example over here. This one's not proportional. It is a straight line, but it doesn't go through 0, 0. So why is it not proportional? We can say doesn't go through 0, 0. All right. So moving right along, if we are given a relationship in a table, not in a graph, and we want to find out if that's a proportional relationship, we are still going to find the ratio of y to x and see if it's constant, to see if it's the same for every pair of numbers in your table. So here are my x's and here are my y's. The x's are always the first set of numbers and y is always the second set of numbers. Even if it's like a horizontal long table, it's still true. All right, so for the first set of numbers right here, let's do y over x simplifies to 1/4. For the second set of numbers, let's do y over x also simplifies to 1/4. And for the final set, 7 over 28 also equals 1/4. So this is a proportional relationship. We already knew that though because they told us right here that it's proportional. So since this is a proportional relationship, then it has a constant of proportionality, and that constant of, oh my goodness, that's like a crayon or something. I think it's a colored pencil, but also I shouldn't be calling it COP. Sometimes I abbreviate it COP for constant of proportionality, but I really should be using K. So for this relationship, K is 1/4. It's the ratio of y to x, and it's the same for every pair of numbers in the table. All right, over here, we know that this is not proportional because they told us, but let's tell why. If we do y over x for each pair, we have 2/8, which equals 1/4. Then we have 3/5, which cannot be simplified and does not equal 1/4. And then same thing here, not the same. So we'll just say y over x is not constant or the same. So you compare each pair of numbers, y over x, simplify. If they're all the same, it's proportional. If they're not the same, it's not proportional. And then lastly, if they give you an equation, the equation needs to be in this form of y equals kx, where k is the constant of proportionality. So this one actually seems like it's going to be hard because it's an equation, which we're not too familiar with yet, but all you really have to know is we want y by itself, a number being multiplied by x. And if it's in that form, it is proportional. And the constant of proportionality is so easy to find. It's just the number in front of the x, the coefficient of x. So k would be 8 in this situation. And then the reason why it's not proportional over here is because we're adding this extra thing over here. So it's not, we can say not in the form y equals kx, because it has this extra added on part. So a situation that might have an equation that looks like this would be those problems where you like go into the fair and it's $20 to go to the fair, but then after that it's $5 per ride. So the very first ride costs the most because there's that added fee of the admission to the fair, and that would be a line that doesn't go through 0, 0, because just going to the fair is not $0. Or renting the car, or going bowling and renting shoes costs money to rent shoes, and then a certain amount of money per game. So anytime there's like a base fee, that's what's being added on here. That's what's making it not go through 0, 0, and then it's not proportional. All right, thanks for watching.